Today, we are going to deconstruct delivery. We're going to dive into a really powerful blueprint for turning a big, kind of fuzzy business goal into precise working code. And we're going to do it without all the chaos and confusion that usually happens along the way. Let's get into it. You know the feeling, right? A project kicks off with this brilliant concept, and everyone's excited, high-fiving in the conference room. But by the time it actually gets to the customer, it's not quite right. It's buggy, it's slow, or it just completely misses the point. So how on earth does that initial spark of genius get so lost on its way to becoming actual code? Well, the problem, when you boil it all down, is that value gets lost in translation. It's exactly like that game of telephone you played as a kid. The original business goal gets whispered from product to architecture to engineering, and with every single handoff, the message gets a little more distorted. Key details, critical constraints, and maybe most importantly, the why behind the work, they just vanish into thin air. To stop this from happening, you need a blueprint. You need a system that creates a rock-solid, traceable link from the very beginning all the way to the very end. We call this blueprint the decomposition hierarchy, and it's a framework that makes sure nothing gets lost. And here it is. This is the whole path, the canonical hierarchy. Now, let's walk through this, because every single step is crucial. It all starts at the top with the core problem you're trying to solve. That then defines the business outcomes you're aiming for. From there, you figure out what system capabilities you need to build. This lets you define very specific functional and non-functional requirements, which then get bundled into these large, value-based epics, and are finally sliced into deliverable features. See? Every single step is connected, one to the next. So let's just put a formal definition on it so we're all on the same page. The canonical hierarchy is a structured method for breaking down a business problem into traceable, outcome-based engineering tasks. And the goal is so simple, but it is so powerful, to make sure absolutely nothing gets lost between that initial concept and the final code. Okay, so that's the theory. Now let's get into the practical side. How do we actually take all those requirements and slice them into work that an engineering team can actually build? This is where this whole hierarchy thing really starts to move away from older, less effective methods. The old way was, it was simple, but it was wrong. It was just a one-to-one mapping. You've got a requirement, you make a feature. That's exactly how you end up with a product that feels fragmented and just doesn't make sense. The new way is all about synthesis. We distill all the requirements, the functional, the non-functional, everything, into one cohesive, outcome-based delivery plan. Now, in this system, an epic isn't just some big folder you dump random tasks into. No way. It's a big chunk of value. And here's the crucial point. Every single epic has to be defined by a clear business outcome. It's not build the settings page, it's enable admins to securely configure tenant permissions. It's always about the value, not the UI. Okay, so you have your value-based epic. How do you slice it up into manageable pieces? You use something called the service test. For every potential piece of work, you ask this one simple question. What distinct service does the system provide here? Seriously, this question is the key to creating clean, independent, and demonstrable features. And answering that question, that gives you your features. A feature is a distinct service. It has to be small enough that you can ship it in a single release, and this is critical. It must be independently demoable. This isn't just a tiny story-sized task. We're talking about a vertical slice of functionality that delivers real, observable value to someone. Okay, but what about all the stuff that isn't a flashy feature? I'm talking about security, performance, scalability, the non-functional requirements, or NFRs. So often this stuff is an afterthought, right? It's a debt you promise you'll pay later. Well, this system does something different. It weaves them in from the very, very beginning. Now, what's really cool about this is how every single NFR gets a specific home. There are 3 places it can live. If it's a huge foundational piece of work, like building a new encryption framework, it becomes an enabler epic. If it's a constraint on one specific service, like this search has to return in under 500 milliseconds, it becomes acceptance criteria on that specific feature. And if it's a universal rule, something like tenant data must always be isolated, it goes straight into the global definition of done. Nothing is left to chance. Following this process leads to one of its most powerful outcomes, a truly intelligent backlog that actively prevents rework and wasted effort. This is how you stop your teams from spinning their wheels and only build what's actually missing. It all starts with an ideal plan. You map out every single requirement the business needs, as if you were building the entire system from scratch. This is your perfect world blueprint. But of course, we don't live in a perfect world. You've got an existing code base. So the very next step is a systematic scan of what's already there in the code to see which parts of that perfect blueprint are actually already built and working. And here is where the magic happens. You take the perfect plan, you subtract what already exists, and you're left with only the gaps. This is the Delta Backlog, a to-do list that contains only the work needed to build what's missing or fix what's broken. No more rebuilding what you already have. This is the key to real efficiency. And this table here shows it perfectly in action. For each component, you just ask, is it required? Does it exist? And based on that, what's the action? You can see right here for the schema, it's required, but it doesn't exist. So the action is build new. But then look at the UI. It's required and it already exists. So the action is none. We don't create a story for it. It's simple, it's logical, and it's incredibly efficient. So you've got this smart, lean backlog. How does that translate into a delivery plan you can actually count on? Well, it turns out all this rigor up front pays off in huge ways when it's actually time to build. You sequence the work based on risk, not just what the user sees first. This is huge. The most critical, foundational pieces get built first. You tackle compliance and audit gaps before you do anything else. You make sure data integrity is solid as a rock. You de-risk any data migrations. And only then do you move on to the shiny, functional user experience work. This is how you build a stable, secure foundation. And let me be clear. This isn't just some theoretical exercise you do on a whiteboard. As you can see from the tooling in this diagram, this entire process, from the initial decomposition to the gap analysis, is actually executed as a sequence of automated skills. It's a repeatable, reliable system for generating high-quality delivery plans every single time. All of this rigor has a real purpose. The structured plan you create isn't just a suggestion, it's a mandatory input for those crucial project checkpoints, proving that what you're planning is feasible before you make a major investment. It's what gets fed directly into engineering tracking systems to kick off the actual development sprints. This is the official entry point to building. So we've laid out a blueprint for delivering value, not losing it. A system that ensures traceability, integrates quality from the start, and focuses your team only on what needs to be built. The final question to ask yourself is this: how could a blueprint for value like this transform your next project?